In this section, I am going to describe what we are going to build and how the various components squeezed in the application communicate with each other. Speaking of communication between the microservice components, we can use mainly two types of communication style, as we are going to see. One of which is called RPC style communication, which is short for remote procedure call, in which communication style a microservice directly communicates with another microservice via a HTTP communication channel. We'll be using this type of communication in two places in our application. And another one, which is the most preferred one, is through asynchronous messaging, of which we'll use a lot in this application. As for the application we are going to build, what we are going to build is rather an unusual type of application, which includes technologies like face detection from an uploaded picture, messaging using RabbitMQ and mass transit, and also SignalR-Core for push notification of changes that are happening in the background to the user interface. The application we are going to build can be described as follows. As regards its components, just think of a fictitious company, Faces and Faces, specializing in face detection, which has just come into being. They do their business via the internet and have a website which has been built for this purpose. The idea is that the users upload pictures in the site, giving their email address, and want the company to detect human faces in the pictures, crop the faces off, and send these to the email address they provide. The company is doing this service free of charge for a period of some months, after which it will become a paid service. So people rush into the site while it's free and get the faces detected and cropped from their pictures. The software development team at Faces and Faces has come up after some lengthy discussions with a structural diagram showing the components of the system that they are going to build, which is depicted here. The diagram also shows the data flow between the components. So let us go over the components now, one by one, while describing the actions that actors of the system can take on the site. At first sight, we can notice that we are going to have four microservice components in our application: MVC Web Client, Orders Microservice, Face Detection API Microservice, and Notification Microservice. We have this MVC Web Client project facing the user actor, whose sole entrance to the system is via this client project. Of course, if we wanted, we could also produce a single-page application, a mobile application, or a desktop client here, in addition to this MVC client. The communication between the MVC web client and the rest of the system is threefold. One is via a HTTP request and HTTP response type communication used when we are querying the orders and their statuses from the orders microservice to show on the user interface. Here, what we call an order is any picture uploaded in the site with an email address attached to it. Second type of communication that the MVC client makes with the order microservice is a SignalR push notification type communication, via which the web MVC client component, acting as a SignalR client, receives information when new orders are recorded in the orders microservice so that it can display them automatically. And the third type of communication is via messaging. The MVC web component receiving the uploaded picture and the user email address sends them to the message bus after preprocessing the image, that is, converting it to a byte array. It does not record or save anything. The data sent to the message bus from the MVC web microservice is grabbed by any component which is interested in it. So here in the diagram, we show this communication between the message bus and the MVC web microservice with an arrow numbered 1. The arrow of direction shows the data flow direction. Our request cycle starts with the register order command when a picture is uploaded and a user email entered in the MVC Web Projects UI following a button press. The command is packed with the user posted data, is received by the message bus, which is a RabbitMQ message bus. We use a RabbitMQ Docker container for this purpose, so you do not have to have RabbitMQ server installed in your local development machine. For message bus traffic from and to message bus, we use mass transit library, which is a NuGet package built on top of the RabbitMQ. It makes our job easier for programming the message, forwarding and receiving. The register order command is picked up by the orders microservice, as indicated by the arrow number 2. So the message comes to the message bus and it's picked by the orders microservice, as indicated by the arrow direction here. We also designate messages inbound or outbound depending on their directions. If the component is in the receiving end, it's an inbound message. If the message is emitted by a component, it's an outbound message for this component as expected. Our order microservice receiving the command data registers this data in its database as an order. The image data as received by the order microservice is in byte array form and it is saved in that form in a database table. And this database server is again supplied by a Docker container. The order microservice then sends this image data and its ID to an endpoint provided by the face detection API microservice, as indicated by the arrow number 3. I chose to use HTTP request response type communication for this operation. Whatever the number of faces in the picture, they are all detected and cropped by the face detection API microservice and returned to the orders microservice as indicated by the arrow number 4. The faces data is again in byte array form, and if we happen to have 2 faces in the picture that we have uploaded, we are going to have a list of 2 byte arrays. And they are saved in the orders microservice as order details of a given order, and the order status is updated to be processed from registered. The face detection API microservice is based on an image processing library called OpenCV#4, built on top of the world-famous OpenCV image processing library. It will use HAR cascade files to detect faces in images. We could later expand this API with some deep learning techniques if we ever need to increase processing speed of the face detection. Once the faces are detected and saved in the orders microservice, the faces data need to be transmitted to the message bus so that our customer notification microservice could pick it up and send or dispatch the order to the customer. Here, order dispatching means sending the cropped faces from the image to the customer via an email. the latest status of the request cycle is made known to the public by the orders microservice by emitting an order processed event message, as shown by arrow number 5. The event message is picked up from the bus by the customer notification service, as indicated by arrow number 6. This microservice is a console application whose sole purpose is to send emails to the customers with faces attached as JPEG images. Once it dispatches the order to the customer, it emits an event as indicated by the arrow number 7. The event is called order dispatched event. This event is picked up by the orders microservice, and the order status is changed to dispatched. Followed by that, the signaler server incorporated within the orders microservice pushes a change notification to the MVC web client, which then refreshes its order list if that page is open. So the admin user looking at the orders list does not have to do a request or refresh a page. It's all handled by the signaler core client JavaScript code, which receives the change and refreshes the page automatically, and thus our whole cycle is completed. All the components of the application will be dockerized and will eventually use Docker Compose to orchestrate our application. So in the next section, we are going to start working on the face detection API. See you in the next section.